Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, well, we're going to answer a question posed, or a series of questions actually, posed by Frank Manera. And before we start, Frank, I'd just like to say thanks for your comments about my book, Drink Tea and Read the Paper, and thanks very much for your question today. So when I answered Frank, I said, if you need to know any more, please drop me a line. And he left me this question, and here it is. It says, I'd like to know your views on why Six Sigma is underutilized, meaning that the big corporations, they should have made more use in every manufacturing unit and process and business endeavors that they do, rather than using it in a few selected units or parts of their company. That being said, do you think there's a catch in the phrase quality is free? If quality is indeed free, then manufacturers and engineering firms should have more confidence in Six Sigma, and maybe by now there could have been a demand for someone investigating 7 or 8 Sigma. In other words, do manufacturers and engineers think that Six Sigma comes with a price tag which is never paid back? So I've made some notes here just to remind me of the elements of Frank's question, but we're going to try and answer him in the best way that we possibly can. So why don't companies use it more? Well, I think, Frank, the first answer to your question is, I don't think that most companies, or most people actually, that even when they send people on black belt training, green belt training, I don't think they even know what they're getting. Okay, so the first thing to say is this. Why don't companies use it more? Well, I don't think they understand the power of this thing. As a black belt, here's the deal. As a black belt, you can fix anything. Any technical problem that comes at me, a design problem, a manufacturing problem, a maintenance problem, I don't care. I can fix it. It's the most powerful thing. Now, if you read about Six Sigma, we're going to take a look what Wikipedia says about Six Sigma in a second. This is a super exciting skill. Six Sigma is highly exciting. The ability to solve, when I say anything, any technical problem. That's what black belts are capable of doing. But let's take a look at what Wikipedia says about Six Sigma, and it really doesn't get you very excited at all. Let's take a look. Okay, so here we are looking at the Wikipedia page for Six Sigma. Let's see what it says. It's a set of tools, techniques and tools for process improvement. It was introduced by Bill Smith whilst working at Motorola. A Six Sigma process is one which is 99.99966 of all opportunities to produce some feature or part are statistically expected to be free of defects. Wow, does that get you excited? Let's have a look at the doctrine. What does it say? The doctrine asserts continuous efforts to achieve stable and predictable process results are vitally important to business success. Manufacturing business processes have characteristics that can be defined, measured, analyzed, improved and controlled. Achieving sustained quality improvement requires commitment from the entire organization, particularly from top level management. But if you read this, and you can read more at your leisure, does it get you excited? Now that's very typical. You can find lots of pages about Six Sigma. It talks about 6 standard deviations between the mean and the nearest spec, and all kinds of statistical nonsense. But what is Six Sigma? It is, without doubt, world-class technical problem solving. That's what it is. It's world-class technical problem solving. And if people knew that it was world-class technical problem solving, maybe they would use it more often in more parts of their business. And that, by the way, means your design function as well. It's world-class technical problem solving in design. You know, as someone now has been doing Six Sigma for 20 years, I have the confidence to say, if you invite me into your company to solve a design problem, I can do it. If you invite me into your company to solve a manufacturing problem, I can do it. And I don't care what industry you're in, and I don't care what the technology is. Six Sigma has taught me to do that. But most companies, why don't they use it more? They don't know that it's world-class technical problem solving because they read some of this dry mumbo jumbo on the internet, and they don't learn more about the subject. Yeah, so I would say that's probably the answer to question 1. So let's now take a look at question 2. Is quality free? Well, I recently did some work with a client where I pointed out that quality was indeed free to them. And let me show you how and why. They had a process that delivered a capability that looked like this. It effectively, continuously produced defects. It produced defects both on the high and the low side. If you looked at this, of course, on a graph, how would the graph look? Well, unfortunately, it would look very chaotic and results would be going above and below the top and bottom tolerance. Now, if you have a process that looks like that, what have you got to do? Well, you have no choice but to do 100% inspection. And you can't avoid that. Now, when someone comes along and says, oh, we want Six Sigma, we want 3.4 defects in a million, what do companies think? Well, they think they've got to do more of this because they're going to have to inspect it even closer than that. And they somehow get scared that quality is going to cost them money. But here's the deal. If you can get this process under control, if you can remove the chaos in this process, and you can make it look like this, and by the way, this doesn't take much to achieve this, so you're going to squeeze the chaos in, and then of course you're going to apply control limits to this thing so that if you produce one here, it will give you a signal to get this distribution centered. You only need 1 or 2 data points to make that decision. So now, instead of measuring 100%, maybe you're going to measure 1 or 2 just to center it. And then you can take your hands off and leave it, because the quality now is free. That machine is just going to go bang, 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 and it's just going to spit out good parts all day. Now, maybe you've got to check it every now and again just to make sure that nothing's gone wrong. Maybe you check at the end. I check the last stuff personally. These people make small batches, so 50s, 100s, etc. But they currently have to measure 100%. And by the way, it's not a cheap check. They have to do this using a coordinate measuring machine because their tolerances are so fine. So this is super expensive quality to them. They do 100% inspection on a CMM machine. The CMM costs something like £60,000 for Christ's sake. They have to have a skilled guy. They have a bottleneck of people waiting because all their machinery has to be measured through this thing. So the use of their machinery there, OEE, is terrible. This is costing them an absolute fortune. This, you don't have to measure it at all. We don't need the coordinate measuring machine except for the first 1s or 2s. And then sit back, drink tea and read the paper and just count the cash. That is where quality is without doubt free. So here, this is really where quality is free, because once you've got a great process. And by the way, this isn't difficult to achieve. What would the 3 things be that I would say? Number 1, make sure you do machine maintenance. Maybe 4 things. Make sure you've got a repeatable setup routine. Make sure you've got standard settings that are never moved. And finally, make sure you use SPC. And if you use SPC, you know, you've got to do this anyway. You've got to do machine maintenance, so that's not costing you any more. It's just making sure you do the discipline to do it. Do what you promised to do. These two, once they're written down, it's just following the routine. And by the way, if you get your setup repeatable to a set standard, it gets faster. So you're going to do the setups quicker. The machine is going to work right first time. The efficiency of the machine is going to be better. Is quality free? Well, certainly you make more money if you've got quality. And you just need to do 4 simple things in order to get that to look like that. Measure 1 or 2, and quality's free. So for me, yes, that is the case. So now let's answer the last question. Why don't we go for 7 or 8 Sigma? Well, actually, some companies should be going for 7 or 8 Sigma. First thing we need to understand is, why did Motorola pick 6? Why did they stop at 6? Well, the reason they picked 6, it goes to the heart of something called your rolled throughput yield. Now, this is really your true factory defect rate, but it's called rolled throughput yield, often shortened to RTY. Now, how does rolled throughput yield work? Well, let's say we have 3 processes in our factory. They all have a 3% defect rate. Now, of course, what most people do is they calculate the average and they say, my average defect rate is 3%. But that isn't what's happening, of course, because if I put 100 pieces in this end, and for simplicity, I'm going to suggest we lose 3 at every stage, and I lose 3, lose 3, lose 3, what comes out the end? Well, only 91 pieces. So actually, you've got a rolled throughput yield really of 91%. And that's your true yield. So your true defect rate there is closer to 9%, not closer to 3, which is what you tend to work out when you work out the average. Now, Motorola, they didn't have 3 steps. They had 3,000 steps. They were making electronic goods, televisions, radios, things like that, lots of electronic components in there. They were touching the product 3,000 times, 3,000 opportunities, 3,000 processes. If 3,000 processes have a 3% defect rate, you won't have to go through too many steps before you don't have any coming out the other end. What do you get coming out the other end? 0 good product. Everything goes in the bin. Now then, 3,000 steps. So they looked and they said, well, where do we need to be then? They said, well, we could be at 3 Sigma, we could be at 4 Sigma, we could be at 5 Sigma. But actually, when you get to 5 Sigma, so 3,000 process steps at 5 Sigma, I think you only end up with 50% of the product coming out the other end. So 5 Sigma. By the way, this is what the car industry asked for, 5 Sigma. They asked for a CPK of 167. CPK of 167 is 5 Sigma. But if you touch the parts, you're going to get lots of defects. If you've got 3,000 steps, you're going to get lots of defects in your final product if you're not careful. But when you go to 6 Sigma, and you go through 3,000 steps, what you get coming out the other end, I think is something like, it's 99.94, I'm not sure of the exact number, but it's close to 100% comes out defect free. And that's why they stopped at 6. 6 was the point where they sort of hit a sensible quality level, and they didn't have to go any further. So that's where 6 Sigma comes from. Now actually what this means is, if you do the same calc for your company, you might only have to go to 5 Sigma to achieve the same things. So you could go on the 5 Sigma course. It'll be a 5 Sigma black belt instead of a 6 Sigma black belt. But there are some companies actually that need to be at 7 and 8 Sigma. One of my clients makes music mixing desks. Again, it's electronic componentry. In their product, they put between 70 and 100,000 components. Many more than this. And actually, if you look at the table that Motorola used to make this decision here, and you look down at 70 and 100,000 components, I think if you're at 6 Sigma, only about 70% of the items will come out defect free if you're at 6 Sigma. Now, they're a company that should be doing 7 and 8 Sigma. So, yes, should companies be going for 7 or 8 Sigma? Yeah, there are some that definitely need it, just as a matter of course, because of what they do. Companies that are at 6 Sigma, should they strive for 7 or 8 Sigma? Well, it depends whether the customer will notice. If the customer will notice this, then yes, because of course they'll get competitive advantage over their competition. And what's that worth? Well, that's worth billions of pounds potentially. But you have to judge whether 7 or 8 Sigma will be spotted by your customer and whether it will actually be worth it in terms of the size of the business that you could create if you go to 7 or 8 Sigma. So nothing wrong with going there. These are all business decisions. Motorola made a proper business decision. They said, what's wrong? What do we need to solve the problem? And how good do we need to be? And that's what every business should do. And if that means going to 7 or 8 Sigma, then go ahead, knock yourselves out. But if it means being at 5 Sigma, then that's okay as well. But you should make a proper business decision. Frank, I hope I've answered your questions. Why don't they use it more? Is quality free? And why aren't we going to 7 or 8 Sigma? And if you want to know anything else, or anybody wants to know any question about any element of 6 Sigma, whether it's technical or the use of it, or you want to know questions about lean and the use of lean, then please drop me a line and I'll make you a video. Thank you.